everybody, and welcome to another episode of React Wednesdays. This should be a fun one here today. So my name is TJ Van Tol. I work as a developer advocate at Progress. And with me, as always, is my co-host, Dan Wilson.
Hey, I'm Dan Wilson. I work with Digital Primates, and we do Enterprise React Consulting. We also curate the Enterprise React newsletter, so if that's your kind of thing, Google it.
Awesome. And today we've got a pretty fun topic of React unit testing, and we have some awesome guests to talk to us about that today. So why don't we start with introducing them? So Eric, do you want to start us off there?
Sure. I'm Eric Elliott. I'm the co-founder of devanywhere.io, which is a software mentorship platform. And I brought a few friends with me, as you can see, Jesse and Sergio, but I got one more special guest.
Love it.
But Baby Yoda is very excited to hear about unit testing.
Baby Yoda is the best at unit testing. All right. Yeah. Take it away, Jesse.
So I'm Jesse. I've been studying with Eric in Dev Anywhere since the beginning of Dev Anywhere. In my free time, I like to play basketball, kind of golf, and just hang out.
And he's a mentor now, too, on the platform.
Yes.
And hi, guys. My name is Sergio. I'm learning React with Eric, and I'm a remote software developer based in Italy.
Awesome. Well, maybe Eric, you could start by just introducing us to the topic, right? Unit testing in React is kind of, it's a broad topic, right? There's a lot to it. So do you want to maybe help us talk about where we're going to be starting and what we're going to be talking about today?
Sure, absolutely. So there's a few things that you need to keep in mind when you're unit testing React components. Number one is to make your components testable. And you can do that by separating concerns. And that's one of the key benefits of React, is that it allows you to easily separate concerns instead of separating things by technology. What I mean by separating concerns is that your UI logic and your application state logic and your side effects should all be in 3 separate buckets instead of all crammed together in one component, right? And the reason for that is that when you have side effects, which are almost universally non-deterministic by nature, it's really hard to test. And when you have your state dependent on that non-deterministic stuff because it's tightly coupled to the side effects, then that can make it impossible to reliably test to make sure that your state logic is behaving correctly. So it's really important to pull those apart into 2 separate modules, right? And keep those things separated. And then the last thing is side effects. You want to have completely isolated from the rest of your app so that you can run all of your tests for your display logic and your application logic independently of running your side effects. And that's the key. That's the key to really understanding how to do reliable unit tests with React components. And before you get started diving into that topic, I think it's important to understand there are 5 questions that every unit test must answer, right? The first is, what is the component or feature that you're testing? And this should be like human readable, right? And it should also be really easy to see that, that quick description and find that in your code base. So organize your code base so that it's really easy to find those things. And you can put that in a description in your test describe block, right? And then you need a human readable description of the behavior that you're testing for. And this should be kind of a functional approach to, if I give this component a number, it should do something with that number, like multiply it by 2 or something. Don't actually put the actual values that you're using in your test there. Just describe the requirement in human readable terms so that when people look at your tests, they understand why it's there. And that test kind of acts like documentation for the expectations of the API of that component, right? And then you'll need the actual value So that should be explicitly stated in your test, and that should usually be the result of calling some function and checking its output, right? And then you'll need an expected value to compare that actual value against. So I found after years and years of doing unit testing with crazy frameworks with all kinds of assertions, I found myself leaning more and more on deep equality assertions. And as I got more and more experienced with unit testing, all of my assertions became deep equality assertions, like almost 100%, because I could very clearly see the expected value and the actual value, and the test reporters would show me the diffs when those didn't match. So now almost all of my assertions are deep equality assertions. And then the last question is, how do you reproduce that thing? And that's just like a reality check on, can I see this test and understand from the other answers that I've given how to reliably reproduce if this test fails, right? Because most of the value of your unit tests come from when they fail, right? So that's the 5 questions every unit test must answer, and you should memorize those and like ingrain them into your brain, and just make it automatic so that you're just always answering those questions for every unit test. And then I have an acronym that I call RITE. It's RITE, and it stands for readable, right? So every unit test must be readable. You should be able to just look at the test and understand why it exists and what it's doing and how it gets the results that it got. Your test should also be isolated for unit tests, which means each test should have its own setup, its own state, and those things should not be sharing mutable state between the tests. Sharing mutable state between your tests is a recipe for rework, because one test is going to make another test break as you add new use cases that you're testing for, and that becomes a chore, a really big maintenance chore. So what I do is I create little helper factory functions to set up my state for each of the tests, and then just every test calls the factory function to generate its very own copy of the testing state, right? They should also be integrated. So the I has 2 meanings, right? Isolated. The integration part is for integration tests, because unit tests are not the only part of the story. If you are only testing your units in isolation and you're not testing them in the context of the running app from the user's functional perspective, then you're missing, it's like testing the bolts for a rocket, but never actually trying to launch the rocket to see if it works before you put real people in it and try to go to Mars, right? So it's important that you do those integration tests before your app falls down in production and your users all fall and cry. Right? So the T stands for thorough, which means that you want to test all of your likely edge cases. So for numbers, that means make sure that it behaves okay when you use a 0, right? Because there's certain values in numbers that can throw things off. Like what happens if it goes into the negative, if it's something that has where negative numbers are valid values. If it goes negative, what happens to your code? Is it going to work correctly? Stuff like that. You want to test the boundaries. So if it's numbers, test what very large numbers do, very small or negative numbers do, and so on. If you're using arrays, make sure that you're testing what happens when you give it an empty array, right? If that's a valid value, what happens when you give it that? And also remember to test your error cases, because anything that involves any kind of asynchronous stuff, there should be error handling code, and you need to unit test that as well, right? So thorough, that's what that means. And that helps us to just make sure that we've got adequate code coverage. Another thing that can help with the thorough rule is before you write the implementation code, write the test for that implementation code. So don't just go and charge into the implementation and write a bunch of features and then write one test, right? So there shouldn't be code for which there is no unit test, very much. That's kind of a loose rule of thumb, but it'll help you get the test coverage that you want. You want to aim for more than 80% test coverage so that you can reliably do continuous deployment without breaking production, right? And that's a topic for another day, because that continuous deployment is a whole other ball of wax. And then the last letter is E for explicit, which means that everything that you need to understand a test should be located in that test. So if you're using setup data or anything like that, call a factory function from within the test. So don't use before each, after each, stuff like that for key critical variables that are going to be used in that test. And that way the readers of the test don't have to scroll up and down and look in other files to try to find out, where is this variable that I'm using in this test coming from, and what does it do, and how does this test even work, right? So that just makes your test suite a lot more maintainable. That's it.
You know, one thing I thought of as you were speaking is, much earlier in my software development career, testing became semi-popular. And my first reaction was, well, this is overhead and it doesn't ship, so I don't have to do it. Later on, I became in charge of an open source framework that was a MVC framework, and it had unit tests. And I picked it up from somebody who put it down. And having those unit tests provided us with a sense of confidence that we could change stuff and push the button and know if we were going to have problems later. And so it almost became a development accelerator later on in the project. But there was a mental journey I had from testing is overhead and unnecessary to testing is insurance and a way to keep your development velocity linear instead of, you know, accumulating more and more time for features. If you wouldn't mind just offering advice for those who hear this broadcast that are somewhere on that spectrum of why they should test and some of the benefits they get from it.
Yeah. So let me start by saying that TDD absolutely changed my life. It changed how I code. It made me a better programmer, because when you write code with TDD, it forces you to use modularity. So TDD with unit tests forces you to separate those concerns so that you can write testable code and get the kind of coverage that you need to get. And in that process, I realized that that kind of modularity was how I needed to architect my code. And before that, I was overcomplicating the architecture quite a bit, having too many things depend on too many other things and know too much about the outside world. And TDD really brought home the lesson of how do I build software that is easy to maintain, components that are easy to reuse, and so on. And it made everything about my code quality 100,000 times better. so much better. And that's just the tip of the iceberg. As a manager, I really appreciate it, because our development teams that use TDD, they're not afraid of pushing the merge button, because we have really good test coverage. If they can like look over the code and it looks good, they will merge, and it'll be really fast and really easy. And you'll see little green lights in your tools like GitHub. GitHub can actually block if your tests fail. And then when it gets unblocked, you know it's probably safe to click that merge button and let the code go out, right? And we set up continuous delivery, so every time a merge hits our master branch, it just automatically gets deployed. And we're not afraid to do that because we have good test coverage, right? And that has really helped. On a lot of times I've seen pull requests. If people are doing code reviews, which is great, love code reviews, they help a lot. But people are doing code reviews and some of the PRs get backed up because they're touching stuff that people are afraid they're going to break, and critical components of the application and so on. But if you have adequate test coverage for those things, just hit merge and do it. It's going to be okay, right?
I've noticed that fear you're talking about, the fear of hovering over the merge button, accumulates over time. Like at some point, it can even get to a spot where you have this protected developer who has a job only because they know some strange arcane section of code. And as a manager or a business, that's a very bad place to be. If they hit the proverbial lottery or a bus, you're in big trouble. But if you have tests, a lot of times you can understand what the code does because the tests provide some more granular documentation of what's supposed to happen and what's not supposed to happen.
Yeah, that's exactly right. A good test suite is also the best technical documentation you can have because it must be in sync with the code, unlike text documentation in a README.
Yeah.
If it's not in sync with the code, it won't work. So,
Well, I know I have some questions on some of the React specific stuff we talked about, but I know you have a demo you wanted to show. So it would now be a good time to like transition into that and maybe use that to show off some of these things in action.
yeah, Jesse and Sergio, you guys want to take over and show people what we're talking about?
Yeah, sounds good.
Yeah, sure.
Ready for me to throw the screen up there?
Let's do it.
All right. There we go. Yep, should see the screen now.
Cool. So what we want to do is create two components. One's going to be an input form that's going to have a button and an input box so that we can add something to a list, and then another component that will actually render the list. So we'll start off with TDD. I'm just going to bring in some imports here. We have React and then the describe from RightWay. And then I'm also going to bring in render from RightWay.
And so RightWay is a separate package you install, right? So it's is it building on top of anything, or is it just sort of its own isolated tool?
I'll let Eric answer that one.
So RightWay came from, we actually built it for the Dev Anywhere website. We had a live coding integration, and we were running unit tests in the browser as the user was using our app. And the API that we developed for it turned out to be so nice that we were like, we should make this an open source testing framework and release it. And that's what we did. And the idea is that it kind of forces you to follow that RightWay acronym and to answer the 5 questions that every unit test must answer. And at the same time, it gives you this really, really simple assertion. And it's got one assertion type, deep equals. And it was built on top of tape. And tape just provides the unit tests have a standard output format that goes to the console. And then lots of different things can read that output format and transform it in various ways. So you'll see we have a colorized version in our watch script that will provide like fancy diffs if the actual and expected values don't match and stuff like that. But yeah, go ahead and take it away, Jesse.
Yeah, I'm sort of fascinated by the only one assertion type, but I'll let you continue. I want to ask 6 questions before you get to write a few lines of code.
Yeah, and to start off, I'm also just going to run this watch script. It's a package you can install as well to just run your tests. And as the file changes, as we save it, it'll rerun the tests, so we can just keep them running. So right now, I'm just starting off with the test. We're going to answer the first question right here, which is what are we testing? That's our input form. So what we want to do is test our input form, if I could spell. And we give it kind of RightWay set up really well, so it kind of helps answer those 5 questions. So we're going to give it a given, an expected value, actual value, and...
Did you forget should?
I did forget the should.
At the top, underneath given? Yep.
All right, cool. So for this component, what we're going to do is render an input form. So I'm just going to do that now. And it's going to be similar syntax to I'm drawing a blank here.
jQuery selector
yes,
API.
jQuery, that's what I was going for.
Which is what inspired the DOM's query selector all API.
So we're going to render this form, and we're going to just give it no arguments because all this form is going to be is an input button, or sorry, an input component and then a button. So we're going to say given no arguments, this component should render the text input field. And then for the expected value, we'll use our selector, and we'll just grab a class called text input and check the length of that class. And we want it to be there, so we'll say that the length should be 1.
I think that should be reversed, like expected should be actual.
Yep. Yeah,
yes.
You have expected and actual backwards.
Yes. Thank you.
Yeah.
So
Okay.
now if I save this test, it should run.
So actual is the thing like you're actually testing or rendering. Expected is like your hard-coded thing of like, this is the, yeah, okay.
Yep.
That makes sense.
So now we can see that we're getting an error because the input form is not defined. So we can now go back to our input form and try to make this test pass. So we're going to need to import React. And then we'll define an input form. And for now, we can just render div. And we need to export it.
And so in theory, this is going to fail the first time because it doesn't have an input in it.
Correct. It still should fail.
Okay.
Do I have a syntax error or something like that?
Yeah, the backslash after div. Close your div tag.
Oh, thanks.
Yep.
Sergio's been paying attention.
Right.
This is why we brought Sergio on.
So now we can see our input form is still not defined because in our test, we're not importing it. So let's import that. Now it's going to fail for a different reason, and that's because the input is not in there. So we can see that we expected 1, but we got a 0. So the diff comes in the test there. So now let's just add that input.
Lost the E on class name.
And save that. And now we have a passing test. So we, given no arguments, we're going to render an input field, and then I'm going to add just type to that.
I just want to make a note that notice we're not testing for the particular tag name that we're using. And the reason for that is because we may want to target multiple targets, multiple platforms. So the cool thing about React is that you can use custom renderers to target the DOM or maybe a 3D API or there's a React Native and so on. But also our UIs tend to change more often than the basic requirements tend to change. And when our UI requirements change, like a designer comes along with another mockup, maybe now instead of rendering that particular thing, we need to render it nested inside of some other tag for styling purposes or just to make the UI work the way that the designer wants it to work. And if you're testing for the particular tag type, then your test will break when we make those kinds of changes.
Yeah, that's a really good point about how to write tests so they're not so brittle. I remember working in Selenium back in the day, and one of the ways it would work is it would walk the DOM and you could give it a path. And those tests always seem to break for what you're just saying. Someone had a great idea. They added, I don't know if you remember rounded corners and divs where you had to put 420 divs. Then all of a sudden your paths are broken and now all your tests are broken. And it just seemed like a very Sisyphusian task. The use of the class here is a more unique descriptor for the thing you're trying to test. Some folks use IDs. Do you have a thought or feeling around those?
IDs are really handy sometimes, but I tend to write really modular code. So there's generally an ID selector can only select one thing from the DOM, right? So that's why you use an ID, is to not confuse it with other things that are also in the DOM that might coincidentally share that class name, but that's not the thing you're looking at right now. But we tend to write really modular code, which means there's not a big chance of conflicting with another thing that shares that particular class name in that particular component scope. So I don't obsess over IDs.
I'm actually curious, what is render using under the hood to actually render this for the purpose of the test?
So under the hood, it uses Cheerio, which returns an object that basically conforms to the jQuery selector API.
Cool. I've always thought that was kind of cool. Back in the day, that used to be like, I had like Phantom.js sort of craziness going on for some of these things, and I still have some nightmares debugging some of those issues. So this looks really, really clean.
This does not require a DOM at all. It just renders text output, and then you can use the selector API to select from that text output.
Nice.
Cool. So we'll just keep moving on with the demo then. And the next thing that we need for our input form is a button. So I'm actually just going to copy and paste this code because a lot of it's going to be reused. So we're going to have no arguments still. But this time, instead of rendering a text input field, we want to render a button. And button class name, we'll just give it add to list button. So we're going to have a really similar test, except for this time we're going to give it a class name add to list button just to be very descriptive of what it's going to do. And then we're still going to expect that it lives in the DOM. So now we're going to have another failing test. So we can go back to our input form and fix that test. So we're going to add a button.
I think the output form of the test, like it's not, or it's worth of note because you can actually see what's the value you get and the value you expect. It's very easy to understand, at least in my opinion. I think it's very, very clear and simple, yet powerful.
Yeah. And I do like the sort of the deep equal sort of thing by default makes this a little bit more readable too. Cause I know anytime I use any sort of testing frameworks, like the first thing you end up like Googling or looking on the docs is like, okay, what are the 17 different comparison functions you have in your library and how do I use them? So it's kind of refreshing in a sense to just see there's just actual and expected, right? And like, that's it.
Yeah, there's zero ramp up to learn how to use the assertions. Literally, nobody needs it explained. Another interesting thing about it is that you'll notice, look at the unit tests in the bottom. You can see, given no arguments, should render the text input field. You very clearly can see why this test exists and exactly what it's there for. But if you read the test description of some random test suite in there, you'll quickly see that not all test frameworks create nice messages like that. You really have to have the discipline of the human readable descriptions. That's why we have the required given and should fields in that assertion.
I think Siri wanted to get in on the test writing process there.
Well, who wouldn't?
Yeah.
More than any other button on the laptop. All right, yeah, so there's our input form now. We have an input to take the thing to add and then a button to actually add it to the list. So now we can start our test for the actual list component, which will render these things that we're adding. So we're going to start off with a new describe block for that. And we'll call it just list.
And while you're typing that up, we did have one pretty good question come up in the chat about just thoughts on like TDD, BDD on apps or code bases that are likely to change significantly in 6 months, a year, etc. Oh, and we lost Eric with that question.
Yeah, I think Eric would be the best to answer that question. Is there anywhere to see the question still though? Because it kind of disappeared a little bit. Okay, never mind. I see it in the chat now.
Sorry, I'm back.
We lost you for a second there. But there was a question about thoughts on TDD and on apps and code bases that are likely to change significantly in 6 months to a year. Does that, if you have an app that's changing a whole lot, do you approach TDD any differently, or it's the same sort of practice, or do you approach things the same sort of way?
So all of our apps tend to change pretty significantly over 6 months. I have we have a lot of work in startups, and in startups, you basically have this app that is evolving very rapidly from nothing to something. And I find that during that, there's so much change and upheaval in the code base that it's really, really necessary to have a really good test coverage framework for you, so that you don't break important things in the process of all those changes. And you will change a bunch of stuff that will invalidate a bunch of tests, but at least it gives you that heads up that you should look like, are these tests still valid? Did I forget to consider something that these tests were considering that I didn't consider in this new code, redesigning the feature? And I find that process to help me keep my sanity. It really helps with managing a lot of change and upheaval, but it also helps in the context of a legacy app that's been around for a long time. We don't even really call them legacy apps if they've got good code coverage, right? For us, legacy is something that doesn't have code coverage, right? Because if it has good code coverage, that means that it's probably pretty simple to maintain, because it was written in such a way to make it modular enough to get good code coverage in the first place. So it's maintainable, it's well tested. It just happens to be mature code in that case, right? And maybe the UI needs to be freshened up and redesigned, but the code is pretty solid. So yeah, both cases where you're starting fresh and you're redesigning things 1,000 times, and also when you've got this big legacy app, unit tests are a good test suite is really important. They also mentioned Bdd versus Tdd, I think, a little bit, right?
Yep.
So Bdd stands for behavior driven development, and the focus of Bdd is to create kind of a shared universal vocabulary that all the stakeholders agree on. So everybody decides what are the words that we use to describe the concepts in our app. And then you write tests using those words, right, in your test descriptions and things like that, from the user's perspective of functionality that they expect to see in the app. So one of the things that I really love about the Bdd approach is developing that shared vocabulary so everybody knows what's what in the app and what we're calling this and what we're calling that. Otherwise, you've got developers, 6 different developers will invent 6 different names for the same concept. And then you'll wonder, why aren't these all named the same thing throughout our code base? That's why, because nobody bothered to write a glossary of shared vocabulary to share with all the stakeholders, right? You do the same thing. You involve the design team, you involve the product team, and you involve the customer and documentation teams, and just make sure that everybody's using the same vocabulary when they're talking about things to keep everybody on the same page. Bdd is great for that discipline. It's also great for the discipline of thinking of things from the functional requirements of the user. So the user says, maybe I'm building a cryptocurrency wallet. I need to transfer such and such funds from one person to another person. That functionality will actually like simulate clicks in the wallet and let you enter the amount to transfer, and then it'll check to make sure that your wallet balance actually changes in the UI. And that's something that you won't get with unit tests, because unit tests are laser focused on one particular component, not on the user interaction and workflows throughout the whole app. So having those kinds of functional tests is really important. Bdd also has another thing where they kind of translate human readable descriptions into actual running tests. I find that part of Bdd not very useful. The idea is that your stakeholders will be able to see your test suite and read your test suite and understand your test suite and see all the tests passing. And yeah, that sounds great, but in my experience, none of the other stakeholders other than the developers ever read the tests. So, but maintaining that link between the test descriptions and the actual implementation code across your entire stack was a very expensive process. I've actually used Bdd for about a year full time, and it was not as useful as I hoped it would be, and it was very, very expensive in terms of just like maintaining our Cucumber links to the actual running code. That part wasn't very useful. But the concepts, the other concepts about the functional user perspective and the vocabulary, spot on, great, do those things.
Awesome. So Jesse, sorry we distracted from your demo yet again. So
yeah, no worries.
You want to take it from here?
Yeah. So we were rendering the list now, and we want to render. So we've got a rudder test for it right now, and we're basically going to say, given a list of in items, we should render those items. So for this, we're actually going to just create some items for it. So we'll call this data, and our data structure will just be objects with an ID and text.
Did you already import CUID?
Haven't yet. I'm going to go up and do it.
So you mentioned before, just you don't like having like before eaches or something that you can't totally follow. So if this data structure was something you needed in multiple tests, would you still create like a function that's like set up some sample data still? Would you still be okay with that as long as it's like an explicit call in there?
Yeah, so I think if this was more difficult, I would just create a function that took some parameters, and then with those parameters created this list of data. So if it would take like a text and then a number and create this list of data with that.
Yeah, they should be able to share access to the same factory function to create the data, but they should not share the same data structures, because that will cause some problems.
So when you're set up, you might create this data structure and then destroy it at the end, but you'd never pass it to another test.
Exactly right.
Yeah, so that's why this is defined inside this describe block too. So it's kind of scoped to this test.
One of
It's
the
also
reasons
nice.
Sorry, go ahead.
I was just going to mention, it's nice to know like what data you're going to use for the test as a test consumer, being able to see what's happening here. If it's a couple lines, it makes sense to put it right there.
So another thing that's important to note is that the reason that one of the reasons that you want to maintain this separation is that when you develop very large test suites, especially when you get into your functional tests, right? It's not so bad in unit tests, but when you get into your functional tests are expensive because they actually hit the network and they have async stuff going on, and it's time consuming to run all of that stuff and wait for network responses and things like that. So especially in the case of functional tests, you need this data isolation in each test case, because it allows you to strip these things down and run them in parallel across multiple machines. And that's how you can keep your test suite runs under 10 minutes on your CI/CD workflows. And I've seen that a lot of companies will develop these gigantic functional test suites that take as long as 24 hours or more to run. And that is just untenable, right? It's ridiculous. It slows down the development process, and it makes it really hard to integrate our code. So it's really important that you should be able to run things in parallel, which means they cannot be relying on the same shared mutable state, because they're going to step on each other's toes when you try to parallelize those runs.
I'll also say from experience that those are the worst things to debug ever. Like if you have tests that are dependent on each other and you don't realize it, good luck, right? Like maybe you find it easily. Like if you're lucky, you get some error message that points you in the right direction, but oftentimes it's a way of losing your sanity too.
Yeah, it's like an evil treasure hunt.
Yeah.
Patented TM.
All right, so for our search input, we're going to just use the same selector we did before. So we have our jQuery style selector here, and we'll grab our items and then just look at the length of those. So we're grabbing the class name item and then just counting the length of it. So we want it to be the same as the data we pass in. So we're going to run that test now, and it should fail for two reasons. So we have not exported the list component yet. So
It's nice to see this process, because you're writing your tests first, which is a commonly recommended thing. And then we're also seeing what failures you get when you haven't done things like forget to import something. And I'll raise my hand as having that happen at least once in my life.
for once a day, maybe.
Yeah.
I'll raise my hand as having that happen at least once a day.
And I'm also literally the worst typer. Like if you stack rank all typers, I'm just awful at it. I learned to type and I was like 8 on like one of those Macs you could carry on the back of the monitor. And I'd learned to type with 2 fingers on each hand. And I think after 30 years, I've now got 3 fingers on each hand and sometimes a pinky. So
Yeah,
I'm impressed you can live code, my friend.
I'm struggling a little bit right now because I don't actually have my normal keyboard hooked up, so I'll use that as an excuse too. But yeah, so we're going to take in our data as props. So I'm actually going to add that as prop types too.
I also find that React stuff can be really tricky to live code because the number of like curly and parentheses like it next to each other too, like especially as you're going to loop here in a second, those things, not to jinx you, but those are the things that are really fun to write live.
Yeah, I'm just proving it right now.
I'm curious too, while you're typing this up, one thing that I know I struggle with, like when I tell people about unit testing, I have them work on like the world's simplest, like something that's going to like parse a date or something, right? That's like extremely clear input and output. But I find I struggle a little bit more with when it comes to UI as to like, what should I be testing? Because like some of these tests are just straight like existence, like there should be a button. But like in a real world like situation, if this were something like a little more complex and not like simple for the purposes of explanation, do you have any like rules as to like where to draw the lines as to like what's the minimum amount like you should be testing for in like a UI situation?
I find existence tests to be extremely valuable.
Yeah.
Especially when you're refactoring, when you're dealing with design changes and you're like cutting and pasting markup from one place to another and changing the layout a little bit and things like that. I find I very commonly miss some of this stuff that I'm supposed to be cutting and pasting and moving around. And those existence tests have saved my hide so many times I can't even begin to count.
It's good to know because sometimes like I sort of lazily skip that sort of thing because I figure, well, like, yeah, I'll catch it. Like if I break that level, something else will catch it or something like that.
Yeah. For a lot of stuff, that's all you need is an existence test. But for some things, like you're going to see here, as he develops his list, we'll just let him do it, and you'll see there's more to life in the DOM than existence.
So we're going to just map over our data here, and we're going to render our lists. And we set our class name with item, I believe. So let's give that. And we'll key it off the ID. Doesn't like that. So now we see we have a passing test for rendering the items that we want. So if we go back to our test, though, this doesn't really prove that this doesn't really satisfy our conditions yet because we're rendering the items, but we're not rendering the text inside the items. So we need a test to test that actually gets satisfied as well. So Rightway has a helper function called match, and I'll import that now. And with match, we can give it the DOM, basically the HTML string, and another string, and it will search that HTML for the string that we give it. So our test will look something like this. We're going to have an assert still.
And presumably it'll be smart enough to exclude like extraneous attributes or things that are in there that you don't really care about for the purpose of the test too. Like if there's some other random like ID in there or something that wasn't necessarily relevant to the test.
Well, you can scope this, right? With the jQuery selector API, you can scope it to just the part of the DOM that you want to test for.
Gotcha.
Plus, you can use a regular expression to select the data that you really want.
That's correct. Match takes a regular expression, so you can fine tune it really well.
Yeah.
So now here I'm going to define our, we're going to call it contains, and we're going to give match the whole HTML for this one, just because that's, it makes sense. It's going to be the whole thing. And then our search input text is going to be just input 1, which is the same thing that we have up here. So now our actual is going to be, we're going to say this contains the search input, and our expected is going to be the search input. And I'm just going to change this to text because it doesn't really make sense.
I'm curious too, is there a reason you put curly braces around this second assertion?
Yeah, so that was kind of going into what Eric was talking about with being able to scope this. So if we wanted to reuse this, but being more specific, then this would kind of block this contains block to only this assertion here. So if we had another one that got more detailed with this selector here, then we could still continue to use our contains in that test.
Interesting. So it's just,
you could also make another assertion for another one of the text in one of the text fields.
So we could do,
and they wouldn't walk all over each other.
interesting. That's it's just intriguing because I would have never thought to do that. I don't think that's a common thing people do, is just create a scope. But I totally get what you're saying though.
We do this all the time in our test suites.
so I'm going to run that test now, and we'll see that it fails. We expected input 1, but we did not get anything. So we can go back to our test now and grab our text and use it. And now we have 4 passing tests.
I think that's the demo, right?
Yeah, that is.
So I want to address, like, one thing that's missing from this demo is that we didn't really test any of our state logic and how our state handling works and so on, right? We don't actually do that in our component test suite. Instead, we also separately develop Redux reducers. And then we unit test those Redux reducers, which are just pure functions. So there's nothing special about that, right? Except that Redux has a couple of things. It's got action creators, which you should be using if you're not using those. Action creators let you, they're functions that you'll call, and they will create the corresponding action for the thing that you want to trigger, the state change that you want to trigger. And then they also have selectors, and selectors basically let you dive into your state and select just part of that state, or calculate values from the existing state. The selector helps you isolate your state shape from the components that are using that state. So the components don't need to know what your state looks like. They just call the selector, and the selector gives it exactly the state that it's asking for, no matter what the state shape looks like. So if you start out with an array of objects, and then later you decide, I need an object keyed by IDs instead of an array of objects, you can make that change without changing any of your views or any of your unit tests if you're using only the action creators and selectors as the public API for your reducer, and nothing else reaches in and tries to grab the state directly.
Yeah, that's so. So it kind of sounds like you almost handle state in a way almost like outside of the scope of the component, so that it lives. Yeah, that's interesting. It's also an approach I haven't taken before, but I guess it makes sense because if you want to also isolate that so it lives in its own space, it sort of would have to live outside.
Yeah, that's the important key. We put our actual program logic completely separate from the components that are using that program logic. We'll put them in the same folder, right? But we'll isolate them in terms of code, the files that they live in, and the tests that we're trying to run on them. So we keep them compartmentalized, and they're separate from each other. And they're also kind of isolated. It's like optical coupling in a circuit. I don't know. I was an electronics nerd as a kid. Like optical coupling in a circuit, there's no like wire connecting those things, right? Instead, they're decoupled by this optical couple uses light to signal instead of wires, so that you don't transmit electricity across a gap, right? So we want to keep those decoupled so that they're not dependent. They don't have hard dependencies on each other, because those kinds of dependencies are the things that lead to breaking, right? So one of the things that I like to teach people in Dev Anywhere is that a small change in requirements should, Sergio, do you want to finish that?
A small change in requirements should imply a small change in implementation.
Yeah, exactly. So if you change your requirements, you shouldn't have to reprogram everything. You shouldn't have to go and fix a ton of other breaking things. So that's key, is to keep these things decoupled from each other.
So I want to encourage people in the chat. We've got probably about like somewhere between 5 and 10 minutes left. So if you have any other questions you want to ask these guys while we have them on, feel free to get those in. We did get a question from Malachi about tests for things like button calls, the submit function. So would you, any like tips on that, or just standard tests for things like event handlers in your code?
So because we have unit tests for our behavior, right, our state logic, and we have unit tests for the presentation of showing that thing, right? Everything that needs to be, like, all the behavior, the thing that happens when you click that thing is already unit tested. So you don't need another unit test for that simulating the click, except for the functional test, right? And the functional test is going to, from the user perspective, actually interact with the DOM. It's going to simulate clicks. It's going to actually hit a real network and hit a real database and bring some data back and present something new to the user. And those tests would be 100% redundant with tests that are just testing, did I hook up this event listener to this thing? And they would add no additional value if you write those as unit tests. So it's just more redundancy, more things to break if you change your UI design or anything like that. So you're doing you're doing more work for no additional benefit. So instead of doing that simulated clicks thing like a lot of people do, instead of doing that, I will actually just have a functional test suite as well as my unit test suite. And these things are separate and they run separately from each other. So my unit test suites can give me real-time feedback without worrying about network, and it's not slow, and you don't have to start up the browser and wait for it and wait for all the clicks and wait for all the typing and all that stuff to see if your test pass. But that is there as an additional source of an additional line of protection in case something breaks.
Are there any other sort of focuses of code you would say should not be tested with unit tests?
Yeah, anything that's hitting an API, hitting the network in any way, should probably not have unit tests, because that stuff is by definition an integration. So instead of unit tests, write integration tests for that stuff. And a functional test is a subset of integration tests. Functional tests is, remember, where the user's actually, we're simulating a user actually clicking around in the UI and interacting with the UI and making sure that the UI changes in response. An integration test is a broader set of those things. It also includes like the particular kinds of integrations. Like we can have a collaboration that says this component and this API should interact, and there are various ways that they can talk to each other, and we're going to test out all the different edge cases for the collaboration between those two units. That's also an integration test. And for integration tests, you actually want to hit the network because you need to be able to test what happens when the network fails, what happens when packets get dropped, and stuff like that. It's stuff that happens in real life.
It does.
Right?
So here's another good related one. What about like third-party like libraries that you need to test? Do you I guess like existence checks with those to like make sure they render? Do you like trust that they're gonna work the way they do, or how do you typically handle that?
They hopefully have their own unit tests, so I don't bother testing those specifically. Instead, we just test that if it's a presentation component you just drop in and it looks good, then we'll just like maybe we'll put a little container around it with a div and a class name, and we'll just select that thing and make sure that it's there. Right, but without actually testing, we're not going to drill into the DOM of that thing and test that it does the thing that it's supposed to do, because it should already be covered. Anything that's third party that has side effects, right? You don't want to try to unit test those, right? But if it has side effects that you have control over, you can call them. You can call the side effects directly. What you want to do is you want to create. We like to use Redux Saga, which lets us test our effect logic, the stuff that handles the success and failures and making sure that we dispatch the right actions in response to those things. We'll unit test that with something called Redux Saga, which is a Redux middleware that just plugs into your Redux workflow. And you can write the unit tests for that logic without actually hitting the side effects, because when you, Redux Saga supplies something called call and put. And instead of actually calling the function that you pass to call, it returns an object literal that just says, here's the function, here's the arguments, and then you can test that that thing happened, right? And put is the same thing, but for dispatching actions.
Awesome stuff. So this has been fascinating. I feel like we could keep going on this all day. I'll put all the call to chat, because we're going to wrap this up here in another minute or two. Anybody, we have a chance for one last question. So if anybody in chat wants to grab that, go for it, or else Dan might take it.
Yeah, and while they're typing that, it struck me that, we talked earlier in the broadcast about maybe a certain amount of fear or trepidation from developers who don't want to take the time to write tests. But, from looking at Jesse's demonstration, the actual creating the test part was not difficult nor time consuming whatsoever. And while you're working on this little part of your application and all the context is loaded in your head about what it's supposed to do and not supposed to do, it's almost just like taking a handful of notes with the structures that you have. I feel like the ask is pretty lightweight, but the benefits really pay off a lot, especially as the application grows in complexity or in staff or both.
Yeah, the benefits are monumental. And I find that after, it took me about 2 years, but after about 2 years of doing TDD like every day, I started to get like a lot faster with TDD than I was before I started using TDD, even though I'm writing like 2, 3, 4 times as much code when I'm doing TDD, right? It's not the actual typing the characters out that is time consuming. What's time consuming about programming is thinking through what should this component do and how does it relate to the other components in my system and what is the architecture of this thing. And TDD actually helps you think through that process in a way that helps you write more modular, more reusable, more understandable, more debuggable code. So I found that it taught me how to write better code. But also you saw as Jesse was typing there, he was getting real-time feedback. Every time he hit save, those tests would rerun and he would know immediately without even, we didn't even load the browser. Did we even show the component in the browser the whole time? Yeah. No, right? But we know that it works. And that fact, if you're not doing that, what you're going to do instead is you're going to load a browser and wait for that browser to refresh every time, right? And then click around to find the feature that you're looking for, that you're trying to work with, and manually test it. So if you're not unit testing, you're still testing, but you're testing manually in a way that's not reproducible. Nobody else can run all those tests automatically, right? So you're creating this automatic test suite that will automatically run and give you real-time feedback in your console as you're typing and hitting save. And without that, you just don't have the same coverage. And you have to remember, oh, I have to test this and this and this when I change that, right?
Well, I hope the developers who listen to this take that point that you just made to heart, because they're going to go back to their desks and they're going to click around in their application to test stuff while they're building it. And I hope they realize that actually is work. And just like you said, it's non-repeatable work. And we should shun non-repeatable work if we can help it.
And actually, we did have a question come in that I think is going to be a great one to end on. So any advice on the best way to start? And maybe we could just make this a point of wrapping up, like any links you guys want to drop to, I saw they were in here in the chat earlier, but maybe we can drop them again, of like resources or blog posts or things that you think beginners after they watch this could look to for like actionable next steps to take for implementing into their own projects.
Yeah, so we have we have, sorry, what was the first part of that question again?
Just best way to get started for people that are new to all of this, especially in like the question was about like medium scale projects.
Okay, so medium scale projects and projects that already exist, you don't try to like bite off everything all at once, right? If you're making a change, write a test for that change. If you're fixing a bug, write a test for that bug. If it's too tightly coupled, break out just the little piece that could be unit testable, right? So if you've got some data that you need to transform, right? You're hitting some API, you got some data back, and then you need to transform it to something else to present to the UI, right? That transformation step part can be a pure function that is unit testable. So break that part out and put that there. And I think we have some links to various articles and resources. I've written a bunch of blog posts.
I just shared one, like unit testing React components, an article Eric wrote on Medium, and I found it very useful when I started, and I think it's a very good resource.
Yep. Yeah. And I'm dropping all these. I'm dropping a link to Right Way and also your post on 5 questions every unit test needs to answer. So those 3 are going to be in the bottom of the chat if you look now, and we'll make sure we get this. If you're watching this on YouTube after the fact, it'll be in the description of the video as well.
Cool.
Well, thanks so much, guys. This was really awesome. I need you guys handy when I need to go write my own unit tests. Like I need you 3 as a service to just come in and look over my shoulder.
Eric Elliott as a service. You got it. You heard it first here, folks.
So there is Eric Elliott as a service. It's at devanywhere.io.
Yeah. Is there any, actually, so that's a good segue. We like to end with just any plugs anybody likes to give. So I know we all have ours. So why don't you actually go ahead and start any plugs you want to give to end off on?
Yeah. Dev Anywhere is a one-on-one live mentorship platform where you get paired with a mentor, like 2 of them are right here, me and Jesse, right? And we work with you for an hour a week live on video, and we can respond to whatever skill level you're at. And we have a whole curriculum on functional programming and unit testing and React. You'll build React projects as you get deeper into the program, and it's been just really, really amazing to see the kinds of career changes that our mentees have. So check it out. It's cool. It's extremely valuable. Jesse, you want to speak to that a little?
Yeah, just definitely agree with it. It definitely changed my career life, my programming life for sure. So definitely would recommend Dev Anywhere for anyone.
Yeah, and Sergio is a mentee as well.
Yeah, I had a huge level up since I started learning with Eric, and I can recommend it enough.
Great.
Awesome. Dan, you want to drop your plug here?
Yeah, I'll mention the Enterprise React newsletter. Once again, our developer staff sort of submit all the articles for this, and that was one of the articles they submitted. Eric was one you did on testing, and so it's a by developers, for developers kind of thing. We don't sell your email nor spam.
Cool. And I'm dropping links to all this. So if you want to check in the chat or the YouTube description, you can find those. And I'll just end by noting that here at Progress, we're running an online event called DevReach in 2 weeks from now. So it's typically an event we held in Eastern Europe every year, but this year, as you might imagine, not happening. So as part of our sort of experimenting with Twitch, we're doing the conference totally for free for everybody on Twitch. So kind of a fun experiment. We'll see if it works. We'll see if it doesn't, but we're going to have some fun regardless. So if you want to check that out, you can sign up. It's a free conference. Signing up all basically does is just make sure that you get reminders and such so that you know that it's going on. And we have a whole React Day too, which should be a little bit of fun. So with that, thanks again, guys. I really appreciate this. This was a lot of fun. And I'll say too, if you're interested in React Wednesdays, every Wednesday at 1, we have great guests on like these guys to chat. So make sure to hop on in and join us.
Thanks, gentlemen.
Thanks for having us.
All right. See you, everybody.
See you.